Hello everyone. So today we are going to discuss the one of the neural network model, the basic neural network model that is called as McCulloch-Pitts neuron model. So that is the first mathematical neuron model. So that is developed by the author Warren McCulloch and Walter Pitts in the year 1943. So this is the first mathematical model developed. So normally this mathematical model is used for the logical function. Okay, so this is the McCulloch-Pitts neuron model. To see the architecture of the McCulloch-Pitts neuron model. So in the McCulloch-Pitts neuron model, we are having the input neurons and output neurons. So the input neurons will be considered that is for it varies from x1, x2, x3 up to xn and xn plus 1. So all the input neurons is connected to the output neuron through the connection link. Each connection link have its own associated weight. See this diagram. So the input neuron x1 is connected to the output neuron y through the connection link w1. Similarly, x2, the input neuron is connected to the output neuron through the weight w2. And it's similarly up to the nth neuron. The weight is connected to the connection link is connected to the output neuron with the weights of W. Okay, so each connection link have its own associated weights that is represented by the W and P here. Here in McCulloch-Pitts neuron model, there are two types of weights. One is called as excitatory weights, second one is called as inhibitory weights. So all the excitatory weights have the same weightage with positive sign. So from this diagram W, all the W's, okay, that is called as excitatory weights. The weight values are in same and the weight also in positive weights. Similarly, the minus P1 minus P2, okay, minus P, that is for called as inhibitory weights. So that values is in negative sign with different values. Okay, and the P1 is minus 2. P2 is in minus 3 or in minus 1 likewise. Okay, but in excitatory weights, all the excitatory weights are in same value. Okay, so this is the architecture of the McCulloch-Pitts neuron model. So normally this neural network neuron model, McCulloch neuron model, so that is compared with the threshold value. The output neuron going to fire or does not fire, that is we are going to fix with the help of the threshold value. So see here, there is the formula for setting the threshold value. Okay, the output neuron, the function of y in, that is equal to 1. 1 means that is fire. When it is fire, if summation of y in is greater than or equal to theta. Okay, similarly the function of y in, that is equal to 0. 0 means does not fire. The neuron, output neuron does not fire. When the neuron does not fire, if y in is less than theta. So the theta is nothing but threshold value, that is we are going to fix that threshold value. Okay, so this is the formula that we used in the McCulloch-Pitts neuron model. See the one best example of the McCulloch-Pitts neuron model. So see here, so John carries an umbrella. Normally I already said that this McCulloch-Pitts neuron model is used for the logical function. Okay, AND gate, OR gate, XOR gate. Okay, we have to apply this neuron model to the AND gate, OR gate, XOR gate likewise. Okay, so see this example. John carries an umbrella if it is sunny or if it is rainy. So there are 4 given situations. I need to decide when John will carry the umbrella. So the situations as follows. The first scenario, it is not raining nor it is sunny. Okay, so that there is no raining, no sunny. So automatically no raining means the input value is 0, no sunny means the input value is 0. 2 input here, x1 and x2. Okay, so the rain and sun. Okay, we have to consider these 2 input. Okay, not raining means so that values is 0, not it is sunny means that is also it's 0. Second scenario, it is not raining but it is sunny. Okay, so what is the binary value here? And there is, it is not raining means that is value is 0, but it is sunny. So you have to consider that values is 1. So here 0 and 1. In the first scenario 0 0, second scenario 0 1, and third scenario it is raining and it is not sunny. So automatically that weight values that is the values here, input values here 1 and 0. Okay, x1 equal to 1, x2 equal to 0. And similarly for the fourth scenario, it is raining as well as it is sunny. Okay, so automatically the x1 is in 1, x2 equal to 1. Okay, so these conditions are to x1 if it is raining will be considered x2 if it is sunny. Okay, so these conditions you have to compare with the logical function. Okay, this is the truth table of the logical function. You will be considered the four situations: situation 1, 2, 3 and 4. So the 2 input is given to the McCulloch neuron model. We are getting the 1 output. Okay, so first input, what is that? x1 equal to 0, x2 equal to 0. There is no sunny, there is no raining. No raining, no sunny. Automatically the two values are 0 0 means the output also 0. Okay, and it is raining, not in sunny. Okay, the values are second situation, that is for 0 1. Okay, 0 1 means the output is in 1. Okay, so on third scenario 1 0 means the output is in 1, and 1 1 means the output is 1. Okay, these situations it's exactly match with the OR function. Okay, you know the logical OR function, logic gate. Okay, OR function, truth table, everyone is very aware about it. Okay, so see here, this situation is exactly, it will be matched with the which truth table, that is for instance OR gate. Okay, similarly, so these some other examples, that is it will match with the, that is AND function, XOR function. Okay, so this is the concept of the McCulloch neuron model. Okay, so this is the first mathematical model. Okay, so mainly this is used for the apply this neural network in the logical function. Okay, thank you.